So here's a video for 3VT about chapter 8, exercise 20. Still about exponential growth, but now we have tables. And you have to say which of these tables show exponential growth and which ones don't. If there is exponential growth, that means that the growth factor, if you go from one year to another, is the same everywhere. If you take a look at the first interval here, we go from 8 to 12. So if you do 12 divided by 8, you get 1.5. So that's the growth factor here, times 1.5. Now if you get the same number here and the same number there, then there is exponential growth. If you get different numbers, then there isn't. So here we do 8 divided by 12 is 1.5. So this is 1.5. And if you do 27 divided by 18, you also get 1.5. So here also times 1.5. So this table has exponential growth. I do need to say one thing about this though, because sometimes these numbers are rounded off a bit, right? These numbers are kind of easy, but sometimes they're bigger, and so this does not have to be exactly the same. If you have 1.5 here, and then you have 1.49 here, and you have 1.51 here, then they're all so close to each other that there is exponential growth. But if they are exactly equal like this one, then there isn't. Moving on to the second table. Here we also see from 8 to 12, so we can know that the growth factor here is times 1.5, because we had the same growth factor over here. But you can already see that this table does not have exponential growth, because there's a 16 here and there was an 18 there. If you do 16 divided by 12, you get 1.33, so that is a different growth here. So that means that this table does not have exponential growth. In fact, this table has something else. This table has actually linear growth. Let me write it down here, linear. Because the increase is the same everywhere. So I'm going to erase this. Here it's plus 4, here it's plus 4, and here it's plus 4. So the increase is the same everywhere, and then it's linear. While in this table, first it was plus 4, then it was plus 6, and then it was plus 9. So that's exponential, and this is linear. Moving on to the third table, we have 50, 60, 72, and 86.4. We want to know what the growth factor is from 50 to 60. So 60 divided by 50 is 1.2. Then we want to know the next one also. So we do 72 divided by 60 is also 1.2. Let me do it again, looks a bit terrible. And here we have 86.4 divided by 72 is also 1.2. Yeah. So the growth factor is the same everywhere. So this one has exponential growth and this one has exponential growth. And that is exercise A. Moving on to exercise B. There the question is, generate the formula n for each table showing exponential growth. So for the first table, we have to make the formula that belongs with that. So the formula, you can write it down like n equals b times g to the power of t. Or sometimes they use the letter I here also. The I stands for initial quantity. The B stands for the starting value. It's the same thing. The N is, we have it over there. The T is there. And the G stands for the growth factor. So if I want to make this formula, then I have to take a look at the table what the starting value is. The starting value is 8. So I'm going to write down 8 here. The growth factor is 1.5 to the power of T. So this is the formula. For the second table, we don't have to make a formula, but we can because well, it's linear. But the question only says make a formula for the exponential growth tables. But I'm going to show you this formula anyway. Here we have as a starting value 8. So in a linear formula, we always write that last, right? The formula is ax plus b. So here we have plus 8, and every time it's plus 4. So it's 4 times t plus 8. Now you learned this earlier, but that's not important for now. And then we have this table. Here we have n equals, the starting value is 50, and the growth factor is 1.2 to the power of t. So this is the whole exercise. Thank you for watching.